Hi, Miss.
Hi, good morning.
Morning.
Good morning, all.
Hi, Miss.
Hi.
Yeah.
Good morning, Miss.
Good morning, all. Okay, so let's start now. You all did a great job in your quiz. I will share the quiz with you and we will correct it together. The quiz was about reflection of light. We know that when light hits a smooth surface, such as mirrors, it bounces off these surfaces. Okay,
Morning, Miss.
good morning, Kareem. يلا يا كريم. Question number 1. What's the type of the mirror shown in the figure? Is it a flat mirror, a convex mirror, or a concave mirror? Here is the object.
I answer.
Yes, here is the object and here is its image. We can clearly see that the image is smaller than the object. So which mirror is this? Which type of mirrors is this?
A convex.
It's a convex mirror. Good job.
Convex.
A flat mirror gives an image of the same size of the object. A concave mirror gives a larger image. So the correct answer is concave mirror. Marlon. We have this diagram of reflection. Which answer is the correct one? 1, 2, or 3?
Um.
1, 2, or 3? Angle of incidence.
1.
1. Angle of incidence equal 40. Angle of reflection equal 50. Didn't we say that these two angles must be equal to
No.
each other? I'll give you another chance. This is a wrong answer. Don't send me anything in the chat. I cannot check it anyway. The angles must be equal to each other, ya Marlon. So which answer is the correct one?
The second one.
In the second one, they're saying that the angle of incidence is 50. The angle of reflection is 40. So they are also not equal to each other. So we'll be left with the third one, ya Marlon. Okay? I will explain why. I'm talking with all of you. You can answer.
Okay.
To calculate, to measure the
Yes,
angle
can I answer?
to measure the angle of incidence, what should I start with? What should I do?
We measure.
90 minus 40.
Measure 90 minus 4.
What's now the first step that I should do now for the
Miss, what
diagram
did you
of
say?
reflection?
I should figure out how much the angle of incidence is.
I cannot calculate it before I do something. What should I draw?
Reflection. I should draw Incidence
يا
rate.
حلا برافو يا حلا. I should draw a normal. Here is the normal. We start by drawing a normal. The normal is perpendicular to the mirror. Then you know that the angle between the normal and the mirror from here to here, it's 90 degrees, since the normal is perpendicular to the mirror. طيب, 90 degrees. This one took 40. How much will be left to the angle of incidence? Here is the angle of incidence. This
50.
one, 50. So I put 90 minus 40. It's equal to 50 degrees. So the angle of incidence is equal to 50 degrees. How did I know? I calculated it. How did I do this? I know that the normal is perpendicular to the mirror. So this one, all of this is 90. طيب, all of this is 90, and this one took 40. So there will be 50 degrees left for the angle of incidence. This one, ya Marlon, is the angle of incidence. Okay? This is the angle of incidence. It's between the incident ray and the normal. Angle of incidence equal 50.
Okay.
The law of reflection says that the angle of incidence must be equal to the angle of reflection. They must be equal to each other. Is it clear for everyone? Should I repeat?
Yes.
Yes.
Do I re-explain?
No.
Okay, great.
No.
يلا يا ملك. Indicate where your face appears to be when you look in a mirror. This is Malak's face. And this is the image of Malak's face in the mirror. شو يا Malak? Which one is the correct answer? Where should the image of your face appear?
A long way behind the surface of the mirror.
Imagine now that you are looking in a mirror. If you go far away, the image also will go far away. If you go closer to the mirror, the image will go closer. So it's always
An equal distance behind.
Bravo ya Malak. Bravo. So look, there is always an equal distance between the object and its image. Okay? So if the object was right here, the image must be. Why cannot move this? The image will be on an equal distance. If the object comes closer, the image of the object also will come closer. So there is always an equal distance between the object and the mirror, and the object and the image, and the mirror and the image of this object. It's always an equal distance. Equal distance. Imagine you are looking in a mirror. You can try it at home. Okay? If you come closer on the mirror, the image will be close. If you go far away of the mirror, the image also will go far away. There is always an equal distance between you and the mirror, and then between the mirror and the image. Clear?
Clear.
Okay, I'm talking with all of you. Did you all understand this?
No, yes.
Yes.
Yeah. Don't please send me anything in the chat.
Miss, can I solve this?
يلا يا مهدي.
Yes, can I?
What a capital letter R looks like in a flat mirror يا مهدي? A, B, C, or D? شو يا مهدي؟
Miss, I couldn't hear you. My internet went off. Now I hear you. Okay, it's D.
It's D, excellent. So it's the same image, but it is reversed, left to right. Okay, it's for sure not reversed upside down, and it doesn't give the same image. So we'll be left with the last choice, which is the same image, but it is reversed. يلا يا حسن مغنية. Which diagram of reflection is the correct one? A, B, C, or D? Hassan Mughni.
Diagram? Yes. It's D.
It's D, perfect. Excellent, ya Hassan. I'm talking with all of you. What's the problem with diagram A? What's the problem with diagram A?
Miss, the
The
angle of
reflected ray.
incidence and reflected ray are not together.
Okay.
We need to them.
There is a problem
Yes.
in the rays. You know that the ray coming down on the mirror is always the incident ray. It's not the reflected ray. And the ray bouncing off, and going off, bouncing off the mirror, it is always the reflected ray and not the incident ray. So this is wrong. Yalla, what's the problem with diagram B?
Miss, the angle of reflection and the angle of
Good job. So they switched the angles. This is the angle of incidence, and this one is the angle of reflection, and not the opposite. What's the problem with diagram C?
Because they put it needs to be normal.
That's right.
They have to be normal. They have to put reflected ray into normal and the normal into reflected ray.
So they switched the normal and the reflected ray. This one is the normal. This one is the reflected ray. Okay, so diagram C is the correct one.
Yes.
And let me remind you that we do not care for the place of the ray. Okay, this is a mirror. You need to tell me, am I drawing the reflected ray or the incident ray? Yalla. Is this a reflected ray or an incident ray?
Incident.
What about
Incident.
this?
reflected.
Reflected. What about this?
Reflected.
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 This.
Incident.
Incident.
Incident. This.
Incident.
Incident. This.
Incident.
Reflected.
Reflected. Bravo. This.
Incident.
Incident. This.
Incident.
Incident. So always the arrow coming to the mirror, the arrow, the light ray hitting the mirror is the incident one, the incident ray, and the one bouncing off the mirror is the reflected ray. Yalla ya Rasha. Last question ya Rasha.
Yes.
Concave mirrors. Where are concave mirrors used?
By dentists.
Good job.
To see the
Bravo. The dentists need a mirror to make a tooth bigger so they can see clearly inside the mouth. So they need concave mirrors. In stores, we use convex mirrors. that helps us see everything. They give a wide image of what's inside the store. So this is convex. Come in cars, we use convex mirrors. So that's all about reflection of light. Reflection of light happens when light hits a smooth surface. What happens? It's an incident ray that hits a mirror. Here is the point of incidence. How do we draw the reflected ray? You should take your set square and draw a normal in this point of incidence. So here is the normal. The normal is always perpendicular. Here is the normal.
To the mirror.
The normal is perpendicular to the mirror. Bravo. We measure the angle of incidence. The angle of incidence is always between the normal and the incident ray. In this case, the angle of incidence is equal to 60 degrees. So we should measure 60 degrees in the second side. Here is 60. We connect the point of incidence with the point of the angle. Here is the reflected ray. Angle of reflection. That's what the law of reflection says. The angle of reflection must be equal to the angle of incidence. Reflection helps us see in mirrors. In a flat mirror, the image of an object is identical to the object. Okay, this is not working. But it is reversed. Okay, so it's reversed, and do not forget that the distance between the object and the mirror is equal to the distance between the mirror and the image. We have three types of mirrors: flat mirrors, and they give an image that has the same size as the object. We have concave mirrors. Here, as you can see, the image of the hand is bigger than the hand itself. So concave mirrors give a larger image of the object. Convex mirrors, they give a smaller image of the object, and they are used in stores and for security reasons. Type. When we send light to mirrors, it bounces off. It is reflected. What happens if we send light to a transparent thing? So look, we sent light to a square of glass. Did the light ray continue its way? Did it continue straightly?
No.
Did this happen?
No.
No, it didn't continue in a straight way. What did the light ray do?
Bend.
It bends. It changes its direction. It bends. So again, did this bented ray continue in a straight way?
No.
No. And again, for the second time, it bends. It bends one more time. So they noticed that when light passes from a transparent place like the air to another transparent place, which is the glass, the light changes its direction and its speed. And also, when light leaves the glass to the air, it changes its direction and its speed. So, when light rays pass from one medium to another, they bend, they change their direction. So, they tried this with other mediums like air and water. Look, they sent a ray of light to water. Did it continue its way in a straight way? Did this happen?
No,
No.
it's bad.
No, it didn't.
It's
This
banned.
didn't. It bends.
It's bad.
It bends. It changes its direction. That's what we call refraction. Refraction happens when light passes from one medium to another medium, and these two mediums must be transparent, like from air to glass, from glass to air, from air to water, from water to air. Okay? When light passes from one of these places to another place, it changes its speed and its direction. Okay? I will use, okay, let me, before I use another picture, tell you that Miss Fatin made a mistake. So when you watch the science video, pay attention that yes, reflection is when light bounces off a surface. So a light ray comes on the mirror and then it bounces off. This is correct. What about refraction? This is refraction. It's not when light bounces off. This is wrong. So please pay attention. I made this wrong. Okay?
Okay.
It's not when light bounces off a
Okay.
surface. It's when light changes its direction. It's when light changes its pathway. Look, what's the difference between reflection and refraction? In the first diagram, this is reflection happening. The incident ray and the reflected ray are in the same place. Okay? Here is the incident ray. It bounces off a smooth surface, such as a mirror, and it reflects with an angle equal to the angle of reflection. The angle of incidence is equal to the angle of reflection. You know now everything about reflection. What about refraction now? What about refraction? Look, here is the incident ray. Where is the incident ray found? In which medium? In which place?
In the
In the air. Excellent. The incident ray is in the air, right?
Yeah.
Where is the refracted ray? Where is the refracted ray?
it's in the air.
Water.
It's in the water. Excellent. Here is the refracted ray. The refracted ray is in water. Okay, so the incident ray and the refracted ray are in different media. They are in different places, and the angle of refraction can be smaller or bigger than the angle of incidence.
Bigger.
Okay, it's how smaller, how bigger.
Okay.
It's according to from where to where the light ray is passing. But the angle of the incident ray and the refracted ray are in different places. طيب, how did we know that light refracts? Scientists were looking to a spoon in water, to a straw in water. They noticed that the spoon looks broken in water. The straw looks broken in water. So they asked themselves, what's happening? That's what happens. We see things when they reflect light to our eyes. So this is a pencil, okay? In order to see the pencil sends light, it reflects light to our eyes so we can see it. Okay? But there is something happening right here. There is something happening right here. The pencil sends light to our eyes. Here is the pencil sending light to our eyes.
What?
The light, these light rays, they do not continue their way straightly. They bend. They bend. They do not continue in a straight way. This is why we see the pencil as broken. Okay? I'll give you other examples. Let me use this. We have a stick in the water. So we can see it. The stick sends, look at these rays. The stick sends light to our eyes. The stick sends light to our eyes. Do light rays continue their way straightly?
No, they
No,
bend.
they bend. They
Wow,
change
they
their
bend.
direction a little bit. This is why this stick appears to be bent. It appears broken. This is refraction. Here is a pencil also. This is the real place, the real position of the pencil. The pencil sends light rays to our eyes. Here are the light rays sent from the pencil to our eyes. They do not continue their ways straightly. This is wrong. The light rays bend and for this reason we see the pencil broken. This is who's singing right here?
Rena.
Ya Hussein?
Rena.
Okay. Here is where the pencil appears. That's refraction. Do you still have any questions about refraction?
No.
No.
Okay.
No. No.
Here is a fisherman. Here is a fisherman. The
Yeah.
fisherman needs to fish. He saw a fish in the water. He tried to catch it, but the fish wasn't in its right place. Why is that? It's because of refraction. In order to see it, the fish sends light to the man's eyes. But light rays do not move this way. This is wrong. Light rays do not move this way. The light is passing from water to air, so light rays must bend. How should I draw this?
It doesn't go in a straight line.
It doesn't go in a straight line. Here is the light ray of sent from the
Then
fish.
it bends to its eyes.
It bends.
It bends.
It bends, so the fish appears in another place. The image of the fish does not appear on the same place as the object. Okay? So refraction is when
Okay.
refraction is when light bends. Light changes its speed and its direction, and the incident ray and the refracted ray are not on in the same medium. How do lenses work? Lenses use the refraction process to work. And there are two types of lenses. Look. Okay, I will stop right here. If you want to watch the whole video, you can go to the science lecture video. Let me talk a little bit about the types of lenses. Okay, here we have two types of lenses: convex lenses and concave lenses. What's the difference? Concave lenses are thin on the edges. Look at their extremities, look at the edges. They are thin at the edges, but in the middle they are fat. Are you still with me?
Yes.
Yes.
Did you sleep, ya
Yes.
Jamaa?
Yes.
No.
Did you sleep?
No. No.
Okay, great, great. Thank you. The convex lenses have thin edges, but they are fat in the middle. The concave lenses, they are fat on the edges, but they are thin on the middle, and they
In the middle.
work in opposite ways. Okay? Convex lenses, they give smaller images, and they put all the refracted rays together. They put them closer to each other. The concave lenses, they give a big image, a large image, and they put the refracted rays away from each other.
They separate them.
They separate them. Bravo, ya Mahdi. So I will repeat. There are two types of lenses. We have convex lenses. We use them to make things smaller, like those in cameras, I think. And concave lenses, we use them like in the magnifier. We use them to make things bigger. Okay? Concave lenses are thin on the edges and fat in the middle. They are thin on the edges and fat in the middle, while concave lenses are fat on the edges but thin in the middle, and they give a smaller image. Let me show you the images that these lenses give. This is a convex lens, and things that are behind are smaller. It's a transparent medium, so we can see what's behind, but it gives a smaller image of what's behind. Convex lenses give a bigger image of what's behind. And that's it. We almost have 5 minutes left. If you still have any questions, or you can, if you want, try to put a pencil in water. Try to do it now. If someone can, this will be perfect to show your friends how things appear in water.
Yes, I can. Miss, I can.
Miss,
I can.
put pencil and water.
Yes, I can.
Yes, but I need to see this.
Miss.
Yes?
Okay. Can I tell
Okay,
you
great.
something?
Bravo, ya Hala. Look. Hala, we need to see the camera. Okay. Okay, we can clearly see, look at the straw. The straw looks broken. It looks bent. So the part that is not in water, look in another place than the part that is in water. Excellent, ya Hala. Bravo, ya Hala. This is because of refraction. Yes?
I did one.
But you're not opening your camera.
Miss, I'm fixing something.
Okay, great, ya Majid. Look, Majid did it too. The pencil appears to be bent or broken in water. Can you see it? Can you see it? Look.
Yes.
Great, ya Majid. Bravo, ya Majid. The pencil appears to be broken or bent. Bravo.
Yes, I did one.
Who else?
Me no, thank you.
It's okay. The idea is that you need to understand what's refraction. Bravo يا رشا. يلا let's see Rasha's activity. Look. Bravo يا رشا. The pencil appears to be bent. It appears broken in water. That's because of refraction. Bravo. Thank you so much يا رشا.
Miss,
Yes?
if we bring like a lot of lights and then we put in front of it a convex mirror, will they get together?
Is a convex mirror, they will reflect. The light will appear on the wall. Is a convex lens? Yes.
Put it in the water. It came bigger.
It comes bigger كمان. That's because of refraction. صح. Bravo, bravo. Thank you so much. Thank you so much, Shahala. Thank you, Rasha. Thank you, Majid. Okay, if you have no more questions, you can leave. You have 2 minutes if you have other questions. So don't forget, reflection is when light bounces off a smooth surface. Refraction is when light bends when it moves from a place to another. Bye-bye.
Okay, bye.
Bye, miss. Bye. Karim, you're raising your hand. Do you have any question?
No.
Okay, bye-bye.
Bye.